Good morning. Sound. Yes. Good morning. Good morning, everyone. Uh, are we here? Where are we? Yes. Oh, I'm actually a little early. Let me take a look at the Discord and see where everyone is. Say hi. Those things. All right, we're live. Boom. Hey, all right. Good morning, Albert, Fatem, Andres. Hey, Arasto. How are you doing? Good morning. Okay. Oh, let's um let's take a few minutes. We're starting a little early, and people tend to show up like more like 5 minutes in. So let's just take 5 minutes to grab a coffee, take a bathroom break, check your email, whatever. Hey, Rami, good morning. How are you doing? Manoj Raj. Oh, I'm not sure if I have seen you around before. Welcome, if it's your first time. How are you doing? Um, and okay, so and where are we? Uh, okay. All right. So what, what are we doing today? I need to. I had a, I had a list of things that I wanted to cover today. What is that going to look like? So I think I'm just writing myself a couple notes here. Don't worry. We're gonna give people a few minutes before we start. Um, what did I want to do? Oh, we're continuing C sharp, right? Oh yeah, that's super important. We have to do. Yeah, I wrote myself a list of what I wanted to cover here. So I'm going to do that. And then, what is it today? Um, what is it today? It's the 12th, right? The 12th of September. Okay. And we are on stream 24 and 25 today. We have a double stream today. Stream 24 and 25. It's been 25 streams already? Wow. 25 streams times an average of a couple hours per stream. That's about 50 hours. You've been dealing with me for 50 hours already? You guys deserve an award, definitely. Oh. Also, I put a little bit of caffeine on this thing today. You're gonna have to deal with me. Yeah. Ooh, and guess what I put? I put nuts. Can you see the nuts? I go to this Armenian store and they have honey with nuts, and then I put honey with nuts in my coffee, and then the nuts soak the coffee, and it's just so good, so good. All right, from Australia, Nick. What the hell? What time is it there now? It's like, what is it like midnight? All right. Okay. Okay. So I have a list of what I want to cover. I have a list of things that I want to touch upon. Um, um, oh yeah, I have a few things that I want to mention. Okay, so we have I'm gonna start with like news in the world of computational design, or something like that. And then we're gonna get a little more serious. Let me change a couple things here on my computer. Oh, and did I tell you I bought a new computer? A beast, like an amazing, like a huge thing. And I'm planning on using it for the live streams. Because like I think my laptop is doing great, honestly, given all the resources in demand, but it's just the fan is just blowing. It's just not great. So I'm gonna start using this desktop computer that I purchased, and it has like a dedicated graphic card for encoding video and streaming more optimized. It's gonna be awesome. I haven't had. I've had all the parts. I bought all the parts. I bought them separately. So here are the hard drives. The here I have the RAM, memory, and I still haven't had the time to put it together and sit down and put it together. I've been really, really busy these days. Oh, and let me show you this. The It's liquid cooled, but I bought this thing. For the liquid cooling. It's got an LCD screen. I can run videos on this thing. I can play videos on the cooler that goes on the CPU. It's so cool. And true story. That's not for scuba diving, but it looks like a scuba diving. Oh my God, you're so right, Albert. It looks like a scuba diving thing. No, this is. And guess what happened? I bought the whole thing, and then you cannot buy an NVIDIA graphics card. They're all exhausted. They're all sold out. So the only one that was available was a Titan RTX, which is really expensive. But I thought, like, well, I'm going to be doing a lot of machine learning anyway, so why not? So I bought it, and then 2 days after, NVIDIA announced their new 3000 series, and they announced like their 3000 series, and it turns out that their highest model is so much better than the Titan, and it's like $1,000 less. So I had to return the Titan, and now I'm waiting for the new graphics card to come out so that I can buy it and save some money and have a better graphics card. The world is crazy these days, things we have to do. All right. Well, I'm gonna turn on the key light. Where are we? Yes, there you go. All right. Midnight, Nick. Oh my God. Well, thank you for being around. I appreciate that you're taking the time to be here. Also, sad news. Like, Dan Schiffman is streaming right now. I didn't know, but I scheduled this live stream overlapping his live stream on Saturday mornings. So I'm sorry that you either are here or you're there. I would not blame you if you chose to be with him. I would like to be with him, but I don't know. Whatever. Well, you're welcome to just watch this offline if you want. Anyway, so let's get started. So, all right. Am I recording? I am recording. Good morning. Howdy. How is everyone doing? Thanks for being here. And welcome to another session of live streaming, computational design, and parametric camp. All right. So what are we doing today? So I have a few things that I want to touch upon, some comments, things that I want to show, but mostly what we're going to be doing is we're going to continue with the Learning C# playlist that I've been putting together. So let me bring this up actually, and let me share my screen. Where is this? Yes, so if you have been following, you may know that we have been working a lot lately on this new playlist called Learning C#, Introduction to Computer Programming for Designers, okay? And it's basically a playlist of micro videos, very short videos, where like 5 minutes, 10 minutes, etc., where I explain one at a time very basic concepts of computer programming. And I am trying to introduce all these concepts in a way and in an order that if you follow them sequentially, then you will be, if you follow them sequentially, it will lead you to learning how to code, basically. I have this order of things is based on the correct, and you see, yeah, Dan Schiffman is streaming right now. Should we check him out? Can we, wait, let's check him out. Hi, Dan. Where are you? Hi, Dan. I love you, bro. Yeah, he's streaming, right? How you doing, sir? Oh, come here, come here. I know. I know. Anyway, sorry. Again, you guys are welcome. Let me text him. Wait. Hi there. Boom. Okay. Anyways, so all right. So yeah, I'm sorry. He's streaming at the same time. I didn't do this on purpose. It's just I'm really busy in the fall. I have teaching every day basically of the week, so I cannot really block one day for just doing the live streams, which I wish I could. Where was I? Yes, I'm working on this list right now. We are done with a lot of the basics, so how to install Visual Studio, variables, basic arithmetic, etc. And today we have a double live stream. So what I'm going to be doing is I'm going to be doing conditional expressions. I'm going to be doing iterations, so for loops and while loops and that kind of stuff. What else do I have? I have iteration, for loops, nested loops. I will do some exercises. So I want to do like just a bunch of like for loops and with different categories. It's my experience that for loops, when you're starting how to code, they can be perhaps like what takes a bit more time to wrap our heads around. So I want to put a bit more time on that one. And then if we have enough time today, which I wish we do, I will get into some data structures. So I will explain lists in C#, I will explain arrays, I will explain perhaps dictionaries, which are not, I don't find them very common in day-to-day use in C#, but they're super, super common in other languages like JavaScript and Python, for example. So I want to explain the concept, at least. And I would like to very briefly describe classes and objects, even though I'm not going to get deep into explaining that until farther down in the playlist, where I will have a full section just dedicated to object-oriented programming, which is the main paradigm that most modern programming languages are based on these days. It's super important, it's super powerful. We need to really get down into that. And I think once I get there, and I also explain functions, I will explain functions at some point, I think there, at that point, I think it will be like a really good intro. You will have like the basics. And I think that's probably about where I would want to wrap up the list of this playlist, and then perhaps I start another list, which is more like advanced topics on C#, for example. I am calling this list Introduction to Computer Programming for Designers because, I guess because I'm a designer, first. Second, because many of the examples that I will be using while I explain this will have to do somehow with design, with like drawing graphical things on the screen, even for the console. I have a student of mine, my teaching assistant, who just found this really, really cool repository of console application games with ASCII art and stuff. So I may get some inspiration from that repo and then bring some of those examples here to the playlist. And I'm also calling it for designers because when I explain these things, I don't want to make too much emphasis on the computer science behind it. I want to make it understandable, intuitive, and easy. So I don't want to get too lost on the rabbit hole of the actual science behind it. So I want it to be a bit more of an applied learning playlist. So that's my current thinking right now. Uh-huh. Now, there's a bunch of other things that I want to comment on before we start. Um, so, first of all, for those of you who might be new here, we have a Discord. Where is the Discord? Yeah, it's here. Um, we have a Discord. We have offline conversations. We share work. We have like a bonfire because it's parametric camp. And Erasto, who's actually on the call, literally was helping Victor recently with a project where they were trying to find the the skeleton of a typeface. I don't know. It was really cool. So I, for those of you who might be new, I'm going to share a link here if you want to join the Discord and follow the offline conversation that we have during the week. I typically post announcements there as well. We also have a calendar. Where is the calendar? We also have a calendar. Where is the calendar? We have a calendar. Get shareable thing. Yes, we have a calendar that I use to post when live streams are going to go live. So if you follow that calendar and you add it to your Google Calendar or whatever, then you will see the events popping up on the screen and on you. Also, if you like what you see here, please feel free to subscribe and to stay and hit the notification button so that you get notifications when we go live and when we post new videos. And I want to share something really cool. All right. Yes. Where's my Instagram? Okay. So, for those of you, this is really nerdy. Okay. For those of you who may not know this, there is this thing called the Ig Nobel Prize Awards, which is a ceremony that happens here at Harvard every year. And it's like a super, super fun ceremony because what they do is that it's basically like a parody of the real Nobel Prize awards, and it's given to papers or to research that, in their own words, makes people laugh, but then it makes them people think. So it's really interesting because it's really funny papers. So, for example, people. I was there last year, and there was like a paper that was researching the magnetic properties of cockroaches. So whether if you could and how they differ between whether if they were live or dead, and they showed this thing where they magnetize cockroaches and they stuck them to the fridge. I don't know. This is something really bad now that I'm saying this, but it was really interesting, and the idea was that it was research that made you like, hey, what the hell are these people talking about? But actually, it had really interesting research behind it, as saying oh, it turns out that magnetism in animals affects the animal different when they're alive or when they're dead. So which is an interesting property actually. Or they also gave an award to this physicist who wrote a paper about whether if cats were liquids, and showed all these really funny images of cats inside of vases and boxes and stuff. But the paper was basically a proxy for discussing the properties of liquids and trying to find out a formal definition. All right. So it's a really funny ceremony. I was there last year. I'm gonna pull up my Instagram because I have a really funny video from the ceremony last year. Where is this? Here. I don't know if you can see it, but we were in Sanders Theater at Harvard, and this was the ceremony, and there was a target, and we were all throwing paper planes at the target. This is the main amphitheater at Harvard. It was really, really funny and really nice. And I'm bringing this up because this year the ceremony is not happening physically. It's only happening online, and they have opened it up to everyone. So if you're interested in a really nerdy event but also very funny about science and humor, feel free to come here. And I think it's on Thursday next. It's Thursday next week in the afternoon. Okay. You can also watch the recordings of all the ceremonies from the past. But it's a really nice, it's a really funny. If you're nerdy, you should definitely check it out because it's going to be a lot of fun. I also want to. So yeah, so that was one thing. Another thing that I want to bring up is you. I just started Introduction to Computational Design again. We've been teaching. I've been teaching the class this semester for a full one for a full 1.5 weeks, I believe. And and So you know that I teach this fundamental introduction to computational design at Harvard, and you last year we open it's a course that it basically introduces students to the art of computational design by discussing a lot about computer programming, a lot about computational geometry, a lot about creativity enhanced by technology. So for those of you who may not know it, all the lectures from last year are open source. So if you want to check them out, you can go here. I'm just going to paste the playlist there. And this year we started again. I'm teaching the class. We have even more students than last year. But it's different because it's purely online based. So what I'm doing is I am recording most of the lectures offline, so that when we meet on Zoom, we have time to like actually engage with each other and talk and have discussions. So I still haven't decided which model I'm going to follow for sharing the content of the class this year. I have the lectures that I'm recording, and I'm making them available for the students. I want to find a way to open source those as well. I'm also using a lot of this content as support material for the teaching that I do when it comes to technical stuff. So I'm following this hybrid model, but I haven't decided yet how to what this year, what open sourcing that content is going to look like for this year. So as soon as I figure that out, I will share that with you. So don't worry about that. I'll keep you posted. Especially if you are on Discord, you will definitely find links and find when that's going to happen. Okay. And and last but not least, I just saw the most beautiful Twitter post where this is me. So someone, where is she? Yes, so A Semente Atomente Voz, Isabella Cavalcanti, has been following the C# playlist, and she has posted on YouTube, on Twitter, her notes, like, oh, parametric cam, C#, blah, 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 single, doubles, whatever. I just found this super, super beautiful. So, are you there with us today, Isabella? Are you on the chat? Are you listening? Well, if you are, I found this extremely beautiful. Any more of this that you want to share or post or whatever, more than welcome. Okay? Isabella Cavalcanti. Yes. All right. And with that, I think we're probably good to start, right? Okay. So, all right. So let's start. Now, I want to record here. I want to record a video first that it's about string concatenation and string interpolation. Hey, Isabella, how are you doing? Good to see you. Thank you for the post. It's beautiful. I loved it. With your permission, I'm going to share it on the Parametric Camp Instagram. Okay, and I'm going to give you. If you have an Instagram, could you please message me with your Instagram handle? I'm more of an Instagram person than Twitter, but regardless, if you have Instagram, can you please direct DM me or message Parametric Camp or someone so that I can properly tag you? Thank you. Okay, so I want to record a small video after operation with strings. It's going to be called string interpolation because it will be very useful. And then after that, I'm going to start with expressions and everything. Okay? All right. Okay. Woohoo. And of course, as usual, we will do, after we finish recording today at 2 p.m., the first session, I will do like a little bit of Q&A, but then this afternoon at 2 p.m., I will keep recording, and then I'll do perhaps like a more extended Q&A session. Okay? Any questions? Any comments? Anything you want to talk about before we start? Okay, so let me get ready. Let me open up. What am I doing here? Let me open up Visual Studio. What is it today? It's the 12th. Let me open up Open Studio. Operations with strings, operation precedence. Okay, operator precedence. So I'm going to open this. Okay, and I'm going to save it as 13B. Whereas, okay, and I'm going to save it here as, and this is going to be string interpolation. What is going on here? Oh, God, okay, dumb. All right, let me just do it the old-fashioned way. I'm just going to copy-paste the files. And oh, this is really dumb. Okay. And here in program, yeah, no, that's not the one. Operations with strings, and that's what I want. Yeah, that's not the one that I want. Maybe if I take basic arithmetic, is this what I want? No. I'm going to stick with this one. I'm going to stick with this one, I think. And I'm going to create a new project, and it's going to be create a new project. It's going to be .NET framework, and it's going to be called 14B string interpolation. And I'm going to just put it on the desktop in the meantime. Okay. And I was going to use this, but let me just write a quick example. I'm not going to do this. Int A equals 10, int B equals 5, and then int sum equals A plus B. And then I'm going to console Writeline. Writeline this A plus B. Actually, let me do that. Let me do that while I'm recording. Okay, so yeah, I'm going to do that while I'm recording. Okay. Are we there? Yes. Okay. quick sip. The audio is fine, right? Can you hear me well? Some nuts to make me stronger. Sorry. Thank you, Albert. All right. So I think we're ready to go. Okay. Composite formatting. Okay. That's it. That's the technical term. Okay. All right. Oh, somebody's doing construction work. Hold on. Oh, seriously. Ay. Let me close the window. Ay. I'm really looking forward being able to go out so that I can properly set up a recording studio where I'm not bound by this box. You see the box? Where I have like a proper wall and everything. I don't know. Okay, let's get to this. All right. In the previous video, we saw how by using operators, for example, for the plus sign, we can do some string concatenation operation. So for example, let's say that we had two variables, A and B, we added them together, and then we create another variable, which is the sum of those two. And then we wanted to print a message to the console saying like A plus B equals whatever the result, right? I would have to do something like this. I would have to say console.writeline, and then I would have to write this very tricky and tedious like set of concatenations in line. So for example, I would have to say A plus, and I open double quotes, the plus symbol, close double quotes, another plus sign, then the variable B, then I open another, and then I just forgot that I need to add a plus sign here, and then I need another plus sign, and then the result of this, so that I could properly print the result of this to the console. Okay, this is fine. You see, I just got the message there. It's fine. It's just a little tricky. It's just a little tedious to have to like type all of this on and off, etc. It's just not nice to do, So before we go on, I would like to teach you a couple techniques that are specific to C#. Other programming languages have similar ways of doing this, but this is particular to C#, which is called string interpolation. And the idea is that there are shortcuts, or there are ways to insert values inside of a string in a better way, or in a way that is at least a little easier to write and sometimes much easier to read than doing it with just like by concatenating chunks of the string with the plus symbol. And the way this works is when you are, for example, using Writeline from the console class, there's a technique that you can use, which is, let's just write the whole message. Okay, let's just write the whole message. Something is going to be equal to something something, but then what I'm going to do is I'm going to place placeholder sections that I'm going to write with the open and close curly brackets, and I'm going to number them. So I'm going to say something, which I'm going to call number 0, plus another something, which is going to be inside of curly brackets, and a number 1 is going to be equal to another something, which I'm going to label as the number 2. All right? And now, what I can do is, after that, I can open a comma, and then I can pass as arguments to this function the values of all the elements that I want to substitute for 0, for 1, and for 2. So for example, the first one would be A, the second one would be B, and the third one would be the value of sum. All right? And then if I run this code, what the compiler does is that it takes all of these values and it replaces them inside of the 0, 1, and the 2 placeholders. All right? So this makes typing things a little easier and a little faster, and even reading this is a little faster as well. Okay, so this is called Composite Formatting, and it's a way of using placeholders to replace to insert data inside of strings. However, I don't really like this method too much because this only works for the Writeline method. The Writeline method specifically knows how to take multiple arguments, infinite arguments, and start replacing them inside of a string, inside of these placeholders. But it doesn't work generally for all strings. And even if from a readability perspective, it's also not that great. Because like if I were to insert something here now, like I would have to figure out what is the number, etc. So I don't really like it that much. So I'm going to replace this with a very similar version that is called a string interpolation, which works the following way. What I'm going to do is I'm going to open and close my square bracket, my double quotes, but before the string, I'm going to add the dollar symbol, okay? And by adding the dollar symbol, what I'm telling C# is that this string needs to go through the interpolation process. And now inside of it, I'm still going to use the curly brackets as a way of replacing what's inside of the curly brackets with data. But in this case, I don't need to use numbers. I can actually just literally just write in the data type. So I can say, I'm going to write in this. I want the value of the variable A in here. This is going to be a string. B, I want the value of B in there. And then I also want the value of sum inside of this inside of these curly brackets here. So, and then if I do that, you can see that I still get the same result, 10 plus 5 equals 15. But definitely, this, I find it much easier to type and much easier to read. And the advantage of this is that this works anywhere. So for example, I could just create here a string called message and just copy paste this thing, because what this does is that it takes whatever is inside the double quotes and it interpolates with the values from the variables that we pass in, and then I can just now here use message. Okay, so I can use this technique anywhere. And also, even more interesting is the fact that inside of the curly brackets, it doesn't have to be a variable. You can actually write any expression that you want inside of those curly brackets. So for example, I could just save myself this computation by saying, oh, what I want here is actually to compute A plus B, make that calculation, and whatever the result of this, that's what I want inside of the string. And this still works, you know? So it's great. So I like string interpolation very much because it's a very elegant and very fast way of creating composite strings without having to go through the pain of like typing everything down and concatenating strings. So I suggest you give this a try. It's a really nice trick. It's a feature on more modern C# version. So if you're working on some old legacy C# environment, you may not have access to this, but it's a very nice one. So I encourage you to check it out and to try it. All right, so that's going to go here. We're going to do a 4.6b video, and it's going to be called string interpolation. Yes. Okay. So, and yeah. And this project is now done. Oh, I should have closed these other projects here. And let me save this. Let me actually interpolation. Yes. Yeah, we can probably do that. Actually, let me. Yeah, I think the example is cooler if we just save it like this. Yep. Okay, great. So what's next? Any questions about string interpolation? Okay. So if we have no questions, then I'm going to move on to expressions, and that's going to be 20. Okay, so I'm going to create a new project framework. Why do you always send me to stupid repos? I want desktop. Yes, so it's going to be 20 expressions. Yes. Okay. Should I start with some? Should I start with some? Boolean or logical operators. Okay. Okay. Should I start by showing some of these? Should I start by showing some of these? And explain like, hey, there's operators and there are some other operators, equality, comparison operators, and these. Okay, so maybe I could explain this equality operators. Okay. Maybe I should explain a little bit like this. Andres, it can print. So what? Okay. So the question is, can console Writeline print any type of data like integers, doubles, booleans, or other things? In C#, everything, every object. So for example, int a equals 10, whatever. Every object has a method by default called toString. Okay. That you can call any time to convert any object to a string representation. So what console Writeline does is whatever you give it, it tries to find if that method has a toString method, and it converts that object to a string, and then that's what it prints to the console. So if the object has a toString method and it can serialize itself automatically into a string, then that's what you see on the console. If you don't, then what you will probably see is either a description of the type of the object or a pointer to where it's living in memory. But pretty much, yes, it can take anything. It will just represent it as text. However, the toString method implements that representation. Okay, so here we are, operators, precedence. What was I saying? Okay, all right, so I think we can start. So what I'm going to do is I'm going to start with a two values int a equals 10 int b equals 5. Okay. All right. All right, we're going to start a new section where we're going to talk about controlling programs and controlling the flow of a program. And the first thing that I would like to talk about before we actually get into modifying how programs work is I would like to talk about what I would like to refer to as expressions. And the idea is that we've seen in previous videos how to use arithmetic operators to do operations with values, with numbers that yield other numbers, right? So you can add two numbers, you can divide them, etc., etc. However, in computer programming, there are many other types of operators. There are many other types of operations that you can perform with data that instead of giving you numerical values as a result, what they give you is Boolean values as a result. And that's what I'm going to refer to as an expression. An expression is going to be anything that evaluates to either true or false. And the idea is that there are many operators in C# and in any other programming language that I can think of that you can use to compare things and then get a result of true or false depending on that comparison. And that I'm describing this now because it turns out that this idea of comparing things and getting true or false values is the only way, is the only real profound way that we have in computer programs to make decisions. At the end of the day, everything is numerical representations, and any way of making a decision about something, whether to do something or not, or how many times, boils down to figuring out if a certain condition meets, and if that condition meets or not. So if that condition is true or false, then execute a piece of code or not. And we're going to see a lot of ways of how that manifests when writing computer programs. So for example, most of the operators that we will use here will be comparison operators. So we can compare two numbers, see if one is greater than the other, smaller than the other, or if they're equal. And then we can use that comparison as a way to make decisions. So if you're interested in reading more about this, you can go to the operators and expressions section on the C# reference and take a look, for example, at comparison operators or equality operators, and even Boolean logic operators that we will see further down in this series. Okay, and let me show you how that works. Let's say I have two values here. They have two integers. They could be two doubles, but I'm just going to choose integers with the value of 10 and 5. Okay. What I can do here is I can write an expression, for example, to the console. I can just write whether if the value of A is greater than the value of B. Okay, and as I do that, I can execute this code. And then what I will get, sorry, I forgot to add the read key clause so that we can stop the program. And if I run this, what I get printed in the console is the message of true. You see here, I get this is true because A and B, A is greater than B. I can actually say, I can actually write a message, is A greater than B? And then here, I can just pass. And actually, let me do this even better. It's the value of A greater than the value of B. Remember, I'm using string interpolation to create this message here. We've seen this in previous videos. So I'm going to, and then what I get here is 10 greater than 5? It is true, all right? Similarly, I could write, for example, I could copy paste this. I could copy paste this and say is A smaller than B, and then I can pass here A less than B. Okay, and then I can run this, and I can see that this is false. And another thing that I can do is I can compare whether if they are equal. All right. So, for example, I can say, is A equal to B? And then what I do here is that I do two equal signs to compare if they are together. Remember, one single equal sign is not a comparison, it's an assignment. It's taking this value and saving it inside of the variable A. Two equal symbols, that's what you use to compare two things together. And then if I run this, then you can see that I have another message here. Is 10 equal to 5? It is not true. And then if I change this value, so for example, now this is 15, we're going to see that things are going to change. 10 is now smaller than 15. Or if I do 10, both values are 10, then I will get that 10 is equal to 10, true. And then everything else is false. Okay? Let me take a second to write down a few of the other expressions the comparisons that we can see, and then we can take a look at that. All right, so I'm going to write more examples here. Examples of comparisons with expressions. And then here I'm going to say is greater or equal than B, and that's going to be this one. Smaller or equal to B is equal to B. Is it not equal to B? And then here, this is going to be this one. And then any other comparison operators? These are probably what I want in comparison. Yeah, these are the basics. And what will I want to do now? I will want to, we can also save them as Boolean variables. So bool is greater is going to be equal. And I'm going to paste this here, and then we can substitute this here. Oh. So here we go. I created a set of other examples. So we have the greater than symbol, we have the greater or equal symbol, we have the smaller symbol, we have the smaller or equal symbol, we have the equal symbol, and we have the different symbol or the not equal symbol. That one is an exclamation mark and an equality, like an equal symbol. And then if I run this, you can see that I get this plot on the screen. Is 10 greater than 10 false? Is greater or equal to 10? That is true. Smaller is false. Is smaller or equal? That is also true. Are they equal? Yes. Are they not equal? No. All right. So these are all the comparison operators that are available in C# and in most other programming languages that I can think of, really. And they will be extremely useful for us to make comparisons and to compare things together. Now, I want to make sure that we understand that this is an expression that evaluates to a Boolean value. So the result of doing A greater B, the result of that calculation is a Boolean value, which means that in case we were going to make decisions, in case we were going to make a lot of decisions based on whether if A is greater than B, then instead of perhaps doing it on the fly in our program all the time, which is a very cheap operation to do anyway, but in case we wanted to just keep it as a constant value in memory, something that we could do is we could actually just create a variable and then store the result of that in there. So for example, if I create a variable call of the type Boolean, and I call it is greater, and then I store the result of comparing A greater than B, then I will be able to use that value anywhere in the future, because this will be either true or false, right? And then this is going to give me the exact same result that I had before. Now, I have made this comparison, the value of this comparison, a permanent value in my program that I might be able to reuse here and there. Okay, so this is just like mathematical operations. Really, more, it's just like arithmetic operations, but instead of being in the world of numbers, they are in the world of Boolean logic. Okay, and they're operations that result in true or false, and they are the foundations of how do we make decisions in computer programming. Okay, we're going to see tons and tons of examples of applications of these comparisons across this series. So stay tuned for that. It's going to be awesome. All right, those were expressions. I'm going to take 1 minute. I'm going to go to the restroom. I'll be right back. Okay, and we're back. How's everyone doing? Were expressions clear? Expressions are super simple. Are very simple to understand, I think. Okay. So let's talk about conditionals, right? That is cool. Okay, so I'm going to create a new project. That is going to be 21 conditionals. Oh, you're not seeing my screen, right? No. Conditionals. There you go. Are you seeing my screen? Yes, you are seeing my screen. Okay. Oh, where did everything go? Okay. And for this, what we're going to do is we're going to let me open the previous example. There you go. let me remember to execute this. Let me remember to execute this and not have to like force the console on this screen every time I open it up here. And then I'm going to start this, and then yes, I'm going to let okay, so that's good, and this is good here as well. Okay, so where were we? I'm going to explain that I come from here, and then in this program we have just dumped like a bunch of messages comparing these things together. But what I want is just to okay, I got this. Let's do this. Wait, I need to sneeze. Do I? I do, but now that I said it, it's obviously not going to happen. Sorry. Okay, let's get to it. Okay. Oh, before we get to that, actually, let me just okay. So in the previous video, I wrote this example when I was explaining expressions, where I took two numbers and I compared those two numbers with a lot of different comparison operators, and then I just dumped here in the console a lot of messages describing whether if one number is equal to the other, greater, smaller, etc., etc. Which is great, but it's perhaps a little confusing, because what if what I just want is one message that is telling me, oh, A is greater than B or smaller than B, or not just all the information at once, right? The way so far we don't really know how to do that, but this is going to be a good example for me to explain how can we make decisions with computer programming. So whether if I want to print the message A is greater than B, or if instead of that, if A is smaller than B, etc. So this is going to be a really good excuse to explain a new structure that we're going to learn, which is going to be conditionals, and it's going to be using if statements to make decisions about whether if to run certain code or not. So how is that going to work? Well, if statements are a structure that I can use to wrap a certain chunk of code and only execute that code if a certain condition, a certain criteria meets. So for example, let's say that I have the message that I want to say, and I'm going to use string interpolation here, and I'm going to say A is greater than B. Okay? Now this, at this point in this program, this message is going to print always. But what I want to do is that, but if I were to make A smaller than B, then I will be printing basically a false message. 3 is greater than 5. I don't want that. So what I want is, I want to be able to wrap this line of code inside of something that only executes that line of code if A is actually greater than B. Okay? So, oh, wrong screen. Oh, you're right. Why am I sharing? Oh, that sucks. So I've been talking. Thank you, Remy. Oh my God. Okay. All right. So, okay. You know what? That's actually fine, because I'm not sure I was liking how that was. Yeah. So yeah, I'll just do it again. Thanks for the head ups, Remy. Okay, so going back here. So, in my previous video, when I was explaining expressions, I wrote this tiny program that takes two numbers and compares them with operators, and then it dumps all these messages to the console explaining whether if one number is greater than the other, smaller than the other, equal, etc., etc. Which is great, but perhaps it's a little too much information. And what I want to do is I want to write a program that just gives me the one message that tells me how those two numbers compare, if one is greater or smaller or whatever they look like, right? This is going to be a good example for me to describe a new technique that we're going to learn with this video, which is making programs execute code only under certain conditions, only if certain criteria meets. So for example, let's say that I have this new program where I have two values, right? And then right now A is greater than B. So if I print this to the console, then I will get a message that is correct. 10 is actually greater than 5. But if I were to change this, or if during the life of the program it changed, then now the console is printing a message that is wrong. 3 is not greater than 5. So what I would like to do is I would like to either print this to the console only if A is actually greater than B, or print a different message if they just happen to not be greater than the other one. The way we're going to do this is with a new structure that we're going to learn, which is called if statements. All right, and if statements is just a way of writing code in a way that we define that a particular block of code should only be executed if a particular condition meets a particular criteria. So how is that going to work? Well, what I'm going to do is, first of all, I'm going to wrap the lines of code that I want to only execute under a certain condition with curly brackets. So I'm going to do this, and I'm going to move this here, and then in front of this block of code, I'm going to add the word if, and then I'm going to open and close parentheses. And inside of this parenthesis, I'm going to write an expression that needs to evaluate to true or false, describing what criteria needs to meet for this line of code, for whatever is inside of this block to execute. So in this case, because I want to print this only if A is greater than B, then as we saw in the previous video, I can just type A greater than B, and whenever this computes, if this equals true, then all the code inside of this block will execute. Otherwise, the computer will just keep going, right? So for example, if this was 10 and I execute it, you can see that this line of code executes. But if I were to change this back to the number 3, you will see that I will get no output in the console. Because since this was not since this was not true, then the computer totally skipped this block of code. All right? Does that make sense? So this is a super simple. Anything that you write in here needs to be able to be crunched into something that evaluates to true or false. All right? So now we have a program that is a little bit smarter, so it can decide whether if to print or not this message, but I want to make it a little better. So I want to make it so that it can also print whether if A is smaller than B, right? So something that I could do very easily is I could just copy paste this and say, well, if A is greater than B, print this. But if A is less than B, then just print A is smaller than B. Okay? Which means that now A3 is smaller than 5. And if I were to change this, now what I get is 10 is greater than 5. Correct? All right. Wonderful. So my program is now much better because now I can print one condition or the other condition. All right. So it skips this block of code or it keeps this other block of code here. Right. However, if structures can be made smarter by chunking together, combining together, concatenating together series of instructions and series of conditions. What do I mean by this? In this particular case, because we're comparing two numbers, right? Whether if one is greater than the other, we know that if this is going to be true, because of the nature of the comparison we're doing, greater or smaller, we also know that this will be false, because just mathematically those two things cannot be true at the same time. So we know that these two conditions are mutually exclusive. However, right now, the way we have written this program, both conditions are checking. The computer is checking if A is greater than B and then executing this. And even if this went through and it printed to the console, the computer is also going to check for this condition. So in a way, we're wasting a little bit of computer resources because we know that if this was true, there is no necessity to check this anymore, right? So even though comparisons of this kind are extremely cheap for a computer to do, from a computer programming perspective, it's much more elegant to just join the two conditions into one single if statement that executes one thing or the other. And the way we can do that is that we can concatenate these two conditions by saying, if A is greater than B, do this. Otherwise, else if, and then I can print here the other conditions, else if A is greater than small, then print this other one here. So what I'm doing here is that I'm saying, if this were true, run this and then finish the if conditional. Otherwise, if this was false, then try to check if this was true and then print this other way here. So it's going to be either one of the other. If this was true, the computer will stop checking here. If this was false, then the computer will continue checking any other of the conditions that can go after that. So is this going to work? It is going to work. 10 is greater than 5 and 3 is smaller than B. Okay? And I could copy paste as many of these as I wanted. You can add an if statement must start with a simple if, all right? But then it can have as many else if ifs as you want. In this case, it doesn't really make much sense what we have here, but you could concatenate as many as you want. Now, are you already thinking of what I'm going with this next? Which one of the conditions of the possibilities we have not yet accounted for in this comparison program? We have not accounted for the fact that these two numbers might be equal. Okay, so if they are equal, you can see that none of the two conditions actually meet. And if they don't meet, then I'm printing no message to the console. So my program has a tiny corner case. We usually refer to this like very very strange, very rare conditions that sometimes only meet. You know, it has a small corner case that we haven't really accounted for. So how could we print another message saying that A is equal to B? Well, as I said before, we could say, well, else if A is equal to B, then A is equal to B. Remember that when we want to compare if two things are the same, we use two equal symbols. All right, one equal symbol is assignment. Two equal symbols is comparison. This is a really common confusion and something that we forget very often when we start programming. Okay, so we could add this, and this program will work perfectly because now we will actually get this done. 5 is equal to 5. Okay. The only thing that I'm going to show you is the fact that in our particular example, in this one example where comparing two numbers only has 3 possible outcomes, one is greater than the other, one is smaller, or they're equal. Because if this is false, and if this is also false, due to the nature of this comparison, it follows arithmetically that they have to be equal. They must be equal. Therefore, this check is redundant because I know that if the computer got to this point, it's because the only option that is left is that the two numbers must be equal. Therefore, I can actually save myself this check by removing everything and then just finishing an if structure with the last clause, which is going to be else, and then printing this here. What this means is that when you finish an if structure with the word else, it means if anything that you have checked before was false, then the last resource, just execute this code. So if the computer got to this point, then no matter what happened before, and no matter any other checks, this code is going to be executed. All right? So this is the way how you write if statements. You always have to start with a simple if. Then in the middle, optionally, you can have as many else if, else if, else ifs as you want, but they're optional. And also optionally, you can end the if statement with a generic else. If everything before this failed, then execute this piece of code here. But this is also optional, okay? And this is how you make decisions. This is really, really the bread and butter of computer programming. If statements and an expression that evaluates to true or to false. Through the course of this series, we're going to see probably like 1 million examples of applications of this. Okay, so stay tuned for that. All right. Okay, yes, you were looking at the folder. That sucked. But it's fine. Okay. All right, so now what is next? Logical operators. Oh, what is going on here? What is going on here? Okay. All right, so this was conditionals, and then let's do logical operators. How am I going to do logical operators? Maybe I should start with a simple example. New, what am I going to do? I don't need this anymore. And I can do a new project, and that's going to be Net Framework, Logical Operators. Should I bring back the C#? Logical operators. Okay, yes. So I'm going to bring this here. Okay. And then I'm going to start with 2 Boolean values. A equals true and bool A equals false. Console Writeline A. And then console read line, the key, okay. And then what are we going to do? We are going to make a bunch of examples. So I'm going to describe the not operator, the and operator, and the or operator. And then I'm going to write another example where I'm going to where I'm going to define, yes, where I'm going to show that working. Yes. Okay. I have a question for you. So, for those of you here in the chat right now, if you have been watching the videos, would you rather the videos are a little, like the 5-minute, 10-minute videos, would you rather they are a little bit longer, but have more explanations um, and more examples? Or would you rather just like, this is logical conditions, this is arithmetic, like blah, 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 so that you can speed through the thing faster? What would you rather see? Because I'm always torn between like explaining things a bit more deeply or just like going like, because like otherwise the whole playlist is going to be either 4 or 17 hours. I don't even know. I don't even know where we are right now. Let me know your thoughts here on the chat if you're okay. All right. Okay, so I'm going to start like this. No, you cannot have nested multi-line comments. No. Well, can you? Wait. I mean, you can have things. Let me see. Let me copy paste your stuff. You can have them. It's just that they don't nest because this thing will open, and then the multi-line comment will go all the way until it finds the first closing multi-line comment, and then everything afterwards is just is gone. So this one doesn't work. So you don't really nest them. Even if this didn't exist, this you would not need a second nested comment. This, for the compiler, this is just part of the comment right now. But I can address those kind of questions perhaps like by the end of the stream today. Okay, so let me focus. All right, so Boolean logical operators. Now, we have seen a lot of things that evaluate to true or false, so a lot of expressions, and a lot of computation that we can make by comparing two numbers and then evaluated that to true or false and then making decisions out of that, right? The nice thing about Boolean values and about trues or false is that they also have their own form of arithmetic. So just like you can add, subtract, and multiply numbers, you can do operations with Boolean values, with trues or false, so that you can get more complex, so you can achieve more complex decision making by operating with these values. I'm going to be showing you how to do that with what's called Boolean logical operators. And that is just a really fancy computer science way of just saying how to do arithmetic, how to do operations with things that are not numbers, but things that can only have true or false values. All right? And we will see how that is going to be super, super useful for making a bit more of complex decision making when we're doing conditional statements or other kinds of structures in computer programming. So for example, let's start with this example where I have two Boolean values, A and B. One of them is going to be true and one of them is going to be false, right? And then if I just plain print the value of A to the console, the window shows up on my other screen, of course, because I always forget. But if I just plain print the value of A to the console, what I get is the value of true. So that's perfectly fine. But what if I wanted to operate a little bit with this value? So what if what I wanted to do was to print to the console the opposite of the value of A, right? So the first logical operator that I want to show you is the exclamation mark. And the exclamation mark is a symbol that I can use to flip the sign of a Boolean value. So for example, if I say, can you write line not A? So if I print that, then what's going to happen is that I'm going to print the opposite value of what is stored in there. The exclamation mark is called the not operator symbol because what it does is it negates a Boolean value that is assigned to. So, and similarly, if I printed B and then if I printed not B, then I would get false and then I would get not false, which is true. All right, even lexically, from a language perspective, it makes sense. Something that is not true is going to be false, right? So this is the not operator. Okay, now there is another operator which is called the AND operator, right? Which you can use to compare two Boolean values and then reduce that comparison to another true or false value. So for example, if I ask you, is this line of code long? You would say false. And if I ask you, is this line of code long? You may respond true. But if I ask you, is this line of code long? And is this line of code long? Because at least one of them is not long, then the result of that comparison is false, right? So similarly, what I can say is I can take two values, A and B, and compare them with the AND operator, which is written with two double ampersands, okay? And two double ampersands, what they do is it takes true and false, it takes two values, and then it computes the AND of those two. So the only time two values with an AND operator yield a true result is if both of those are true. If at least one of those is false or both of them are false, then the result is going to be always false. So in a way, it's the most restrictive operation that you can do. And similarly, there is another one that is called the OR operator, which, as you may, and it's represented with two vertical pipes like these ones. And what it does is it compares things with the OR logic. So if one thing is true or false, then what is the result of that? Is this line of code long, or is this line of code long? Because at least one of them is true, then the result of that operation is also going to be true. What that means is that true or false equals true, as you can see here. Okay? So two things that are true, true or true equals true. True or false also equals true. False or false equals always false. Okay? And actually, I think it would be probably easier to write it like this, right? This true and false, you know, and then perhaps this is easier to type. Yeah, probably this is probably easier to understand. Yes. You see? So this is how you use Boolean comparison operators or Boolean operators to make comparisons or to create expressions with values that are true or false. Let me show you an example of how we could use this technique inside, for example, of an if statement to make even smarter decisions or more like fine-grained decisions. Let me write that and show you that in a second. Okay. Alrighty. All right, so it looks like people are voting for shorter videos, huh? I do like, Isabella, I do like your idea of having the GSD videos as a longer thing and then having these more like bite-sized videos. That's kind of nice. So let me bring this back to not A, B, and B. Okay. And then let me open a new project. This is going to be seriously whatever. 22B logical operators. Okay. And then here I'm going to say some values I want to compare, and that's going to be equal to, for example, value of 2, int minimum is 0, int maximum is 5. And then I'm going to write this here, console, readline, read key, and then I'm going to write this here, and I'm probably going to do it's outside the minimum, it's outside the I can just this one here. Okay, so I can just copy that. Let's see if value is where value falls in the min max range. Okay. And is okay. So I think I probably want to do at least 4 nested for loops today. I don't know what I'm falling with that. Let's see where value falls. Okay. So what if I did some live streams tomorrow? Can I do that? Because I really need to record a bunch of this video. I'll think about that throughout the day. Okay. Let's see where value falls in the range. Okay, so all right. Okay, let's do this. Okay, so I have prepared this example, and what I've done is I have created 3 numbers. So I have created like a value of the type integer, and then I have defined 2 boundaries, the minimum and the maximum, right? And what I want to do is I want to print to the console, like in previous examples, I want to print how this value relates to the range, the numerical domain that I have formed between minimum and maximum. So I want to print messages like, for example, is 2 within 0 and 5, is outside of 0 and 5, or is exactly at the boundary of between 0 and 5, right? So what I'm going to do that, because now I need to compare the value of 2 to 2 other values, to 0 and 5, then that's why I'm going to need this more complex way of comparing, of aggregating these comparisons together. Okay, and the way I'm going to do that is by the following. So for example, first of all, which is probably going to be the most typical case, I'm going to see if the value of 2 is outside of the range between 0 and 5. And what are the conditions that what are the conditions that lead me to knowing if 2 is outside 0 and 5? Well, first of all, I know that if the value of 2 is greater than the maximum, then I know that that's going to be outside of the interval. So if value is greater than max, then I'm already going to be printing this message. Okay, value is outside the minimum maximum interval, and this already works. Okay, and of course the window is somewhere else, so I'm not. So I am not here. And what I could do before I knew logical operators is that I could say, well, I'm going to also print whether if value is less than minimum, I'm going to print the exact same message. Okay? But this is not very optimal. I want to be able to, perhaps like on one go, say, well, instead of redundantly copy the same, just create one expression here that checks both things. So what I can do is I can take this, I can remove all of that here and say, well, if value is greater than the maximum, or two double pipes, if value is smaller than the minimum value, then it just so happens that value is outside of the range. So for example, now if I do -3, you can see that I get the printout -3 is outside the 0,5 interval. Does that make sense? All right, what are other conditions that can happen? Well, I can be inside of the interval, right? So otherwise, else if value is greater than minimum, okay? So that can be one thing. Then, or value is smaller than maximum, then here print this is inside. However, this is not the correct operator, because what can happen? What if value was, for example, 13? 13 is greater than the minimum, but it's not smaller than the maximum. So it would give me a wrong error. It will give me okay, I'm messing this up. It will give me a bad error. So for the value to be within the interval, two conditions must apply together. The conditions must be that the value has to be greater than the minimum, but at the same time, and value has to be smaller than the maximum. It's only when those two conditions apply that we can know for sure that we are inside of the range between minimum and maximum. So right now, if I say, well, this is a value of 2, you can see that 2 is inside of the 0,5 interval. Okay? So that's great. But of course, there is yet another corner case that we can run into. Like, what if value is actually equal to one of the values at the interval? Okay, so right now we don't get any message. Okay, so there's two things that we could do. You could assume, well, for me, inside could mean that we are also at the boundaries. So if value is equal to one of the boundaries, then I'm just going to consider that that's inside. So I could just replace this with if value is greater than or equal. Well, actually, that doesn't work. Now that I'm saying this out loud, that doesn't work because it cannot be greater than equal. Well, it can be greater than equal or smaller and equal. Yeah, sorry, that does work actually. I'm really messing this one up. Yeah, so if value is greater or equal than minimum and value is smaller and greater than max, then it is inside. So that's one thing. But if I wanted to be even a bit more specific, what I could do is I could add a third clause where I specify that value is actually at the boundary. So what does that look like? I could just say, well, else if value equals minimum, or if value equals maximum, okay, then print here to the console, value is on the boundary of the, oh, and sorry, I have a typo here, equals, okay. And now, if I run this code, you can see that 5 is on the boundary of the 0, 5 interval. Okay? So this is an example that can show you how truths and falses and conditional expressions can be chained together and can be operated with the logical operators not, the logical operator or, so two double pipes, or the logical operator and, which is represented with two double ampersands. Again, this is extremely common, is extremely useful, and you're going to see this and you're going to use this all through your life in computer programming. Okay, so I recommend like a very nice ampersand tattoo on your arm because it's a really nice, beautiful looking symbol, but it will also remind you of Boolean operators. See you on the next video. All right. Okay. Now, so this was logical operators. I'm going to do the next one. I'm going to start with iteration. Okay. I'm going to take a quick break. I'll be right back. Where am I? Ooh, here. Remy, what is your question? You don't understand why this doesn't work here? If value, so like this? Is that your question? Well, in this very particular case, because I have, because before we have checked if the value is outside of the range, you could say that maybe it works. So for example, let's say that I do here 4, all right? So 4 is inside the 0, 5 interval, all right? And if I do 13, then I get 13 is outside of the 0, 5 interval, all right? However, see what happens. If I do 5 here, this is going to tell me that 5 is inside the interval because value 5 is greater than the minimum, but I'm not checking if that value is also smaller than the maximum. And because I was leading up to an example where I wanted to have a special case, which was like whether if the value is at the boundary, then that's why I chose here to do double ampersands. I also wanted to do an example where I use double ampersands for the sake of teaching, right? So putting or here would work if you were to assume that being on the boundary of the interval means that you are inside of the interval. If you make that assumption and if that's how you want, then that's fine. But if you want to be strict about the boundary, then there is like this small corner case, which is if the value is, however, if you change the order, if you were to put this before here, because now you have checked whether if value is at the boundaries, then in this case, if you were to do this, then the whole algorithm would work. Okay? Because now, when you get here, you've checked before if value is at the boundary. Okay? But I don't like this example because since I'm trying to explain logical conditions, logical operators, I want to have one of the clauses to use the AND operator. But yeah, it depends on how you structure your if statement, basically. All right. So where are we now? Okay. So let's talk about iteration. Oh, that is a big one. All right, so let me start a new file. 2, 3, and that's going to be while loops. Okay. And I'm going to write something. Read key. Is there any C# iteration kind of documentation that I can? Yeah, for statement, iteration statements. There isn't like a general. There isn't. Okay, well then no. All right, so I'm going to okay, 4, 5, 6, 7, 8, and 9. Okay. So how am I going to start this? Simple. Okay, so I think I'm going to do while loops right now, and then I'm going to take a break because I'm getting a headache. And then we're going to go back to live streaming this afternoon at 2 p.m. Eastern time, Boston time. Okay, so how am I going to start? I'm going to start by explaining iteration. The concept that I want to do something. Should I make that its own video? Should I make that its own video? So where I explain the concept, because I'm going to be doing, and maybe it could be its own video. Yeah. So then, what if I actually start a new project that is called or maybe it doesn't need to be its own videos. I mean, it's not really that difficult of a, it's not that complicated of a concept that we're going to explain anyway. All right. Okay, so I'm just going to start. At this point in this series of how to learn how to code using C#, we have tinker a little bit with our first structures on how to decide whether to make decisions on a program. And we have been able to alter the typical flow of a program, which is starting from the beginning and then executing all of the statements on the list one after the other in order. And we have been able to tweak that. We have been able to customize the flow of our program by using conditional statements, if else, to choose which areas, which lines of code should be executed based on a certain condition. So we have been able to implement, imagine the program going we have been able to implement jumps between different lines of code based on particular conditions. All right, so that's what's called conditional statements or conditional flow. But another technique that I would like to teach you is called iteration. And the idea is that we can have programs where we're executing all the lines of code one after the other, but at some point we want to perform an operation so many times that we actually don't want to write all of those lines of codes. We want to write that operation, that repetition, in a programmatic way so that we can just say, can you do this line of code like 100 times with some value that is changing while you're doing this, and then just like create like a loop going to executing those lines of code one after the other and then continuing the flow of the program. Okay, so this is what I'm going to teach you right now, and the techniques around that are called iteration. Okay, and the idea is very simple. Imagine that I had a program and I wanted, for example, to write to the console the first 10 digits. So what I will need to do with what we know so far is say, well, I'm going to start by console writeline in 0, then console writeline in the number 1, and so on, so that I actually end up writing something like this, the first 10 digits. It will take me a lot to type, but at the same time, even if that's what I wanted, it's kind of not the best code, because if I were to say, well, now for some reason instead of 10 I need 15 or 25 or I need 100, I cannot really customize this better than just adding or removing more lines in the code manually. It's hard coded, all right? Everything is just written as explicit code, which is typically not a great practice. So if we can find a way to programmatically, with an elegant structure, say, take this line of code and repeat it 100 times with this one thing, this one value, this one object, this one piece of data that is going to change with each one of those iterations. If there was such a structure, it would save me a lot of time of typing, but it would also make my program more programmatic, more customizable, right? Without having to actually modify the code. So this is what I'm going to teach you right now. And I'm going to teach you several structures and several techniques to perform iteration and to perform repeated operations in a programmatic way when writing computer code. And the first one that I'm going to teach you are while loops. And so let's go to the next video and check how that looks like. All right. So yes, I guess it became its own video. All right, so I'm going to iteration concept. Yes. Okay, so okay, so the videos, I have this, I have this. How am I going to do that? Well, I can start right away. I'm going to start with this. Okay. Okay, so let's do this. So the first structure for performing iteration that we're going to learn is going to be called while structure. Sorry, it's going to be called while. Rewind. Starting over. So the first structure that I'm going to teach you to perform iteration are going to be called while loops, and they're super handy and they're super easy to use. What do I want to say? They're not very popular. Actually, wait. Okay, starting over again. So the first structure that I would like to teach you in order to perform iteration in a computer program are called while loops. And they're the simplest form of iteration that most computer programming languages feature. They're very simple and very easy to use, but they're actually not the most popular one. And I'm going to teach you this one right now because it's going to lead me to better explaining how the actual most popular way of performing iteration works internally. But we'll get to that in a second. So before that, let's go back to the example that we were trying to do. Let's try to write a program that is going to print out to the console the first 10 digits, for example. This would be the manual way of doing that, but as I was saying before, I want a more programmatic, more customizable way of doing that. So the way this could work is, for example, we could start by defining an integer variable. I'm going to name it I, for example, and it's going to start at 0 because we want to start counting by 0. And then what I'm going to do is I'm going to write a while loop that is going to print all those 10 digits one after the other. The way while structures work is that you write them like this. So you start with the word while, and then you open and close parentheses, and you open a curly bracket block. This now should start looking familiar. It's like if statements. They also have a word, and they have parentheses for a condition that needs to meet, and then they have the block of code that will execute. So inside of parentheses, what I need to write is an expression, something that evaluates to true or false, and that expression is going to define what needs to be true for the while loop to keep executing. All right? So as long as whatever is written inside of parentheses is true, then this block of code will keep executing one after the other in cycles. All right? So for example, let's say if I is going to represent that number that I want to print to the console, then what I want to say is, well, probably while I is less than, for example, the value of 10, then I want to be printing to the console the value of I. Don't do this. Don't press enter. Don't execute this. Okay? Don't do this at home. Because, and let me explain to you. While I is less than 10, then print the value of I to the console. But if I were to execute this code, and please you don't do it yourself, okay? I'm going to start this, and what you can see is that, I don't know if you can notice my console. You can see the cursor, how it's going, and how this is flickering. This is happening because right now, the console is printing 0, 0, 0, 0 constantly and infinitely, all right? And actually, my program, I don't know if you can notice, but it's not responsive. It actually got trapped into what's called an infinite loop. And why is that the case? It was the case because during the life of my program, I am executing this line of code so long as I is less than 10. But there is no code anywhere in my program that is changing the value of I so that eventually, at some point, it may actually not be less than 5, and therefore this block of code will stop executing. In a way, because I never changes, the program got stuck. The program got blocked here in this block and is repeating it over and over again. And if this was a real program, my program would have gotten trapped here and would keep executing, and will probably, whatever operating system this is living on, it will probably give me an error like, not responding, I can't do anything, blah, 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 because the program is stuck. It is an infinite loop, and this is one of the most common errors, or one of the most common problems when in real programming out there, right? So your phone, apps on your phone probably get stuck sometimes, and that's because somehow the program got stuck on a for loop that it can't get out of for whatever reason, all right? So how do we fix this? Well, the idea is actually super simple. With what I need to do is I need this value of I to at some point be greater than 10. And if what I want is to print instead of like a bunch of zeros, one after the other, I want to print 0, 1, 2, 3, blah, blah, blah. What I need to do is every time I print the value of I to the console, then I need to increase the value of I by 1 unit, all right? And we have seen before, if you remember from the operators video, we can do it in many different ways. So we can say I is going to be I equal plus 1. So whatever I was before, we can increment it by 1 unit. We can shortcut this to saying, can you increment the value of I plus 1? So plus equal 1, or even for the particular case of having 1 unit, of incrementing by 1 unit, that has its own shortcut, which is I plus plus. All right? So if we do that, then what happens is that we can execute this code. And now the code will start with 0. It will increment the value of I. It becomes 1. It executes this again. 1 is less than 10, so it prints 1. It increments to 2. 2 is less than 10, so it prints the number 2. I becomes 3, so until a point where I is 9. I is still less than 10. It prints 9, and then I increments to the value of 10. And then the next time this is checked, I has the value of 10. At that point, I is not less than 10, and therefore the program keeps executing. It hits the read key, and everything stops. Okay? So this is the typical way you create simple iteration. You basically you usually initialize some value, okay? You typically use that value or some other value that lives in your program to check when this while loop should stay alive. And then while you're doing things in your iteration block, in your while loop, you also often modify that value that you're checking against so that at some point you know that you will finish executing this while loop. Okay? But again, be very careful when you use while loops, because if you forget to either increment the value of I, you will get stuck on an infinite loop that will print infinite zeros, for example, in this case. And very often in Visual Studio is not crashing, but some other programming environments will become unresponsive, and you will actually have to force close all your system. Or if instead of, for example, incrementing by 1, you forget or you confuse or it's a typo, and then you start decrementing the value of I, you will see that I will also never be greater than 10. So now you can see how I'm printing infinitely values that are increasing in the negative spectrum. All right? So this is not printing infinite zeros, but it's also stuck in an infinite loop that it will never get out of. Okay? So, oops, so I can't really get out of this program. So this is the basic way you write a for loop. You start a value, you initialize a value, you check that value for a particular condition, then you do whatever you want to do, and then you increase or decrease or modify that value so that at some point this condition stops meeting, and then you can continue with your program. All right? And then this idea, this structure is so popular that so this pattern of initializing a value, checking that value, and updating that value is so common and so popular that is what actually inspired the next way of implementing iteration that I'm going to teach you, which is for loops. So stay tuned for that one. Oh, okay, I forgot to do, but maybe I just don't need to do it. I forgot I wanted to talk about do while, but I don't think it's going to happen. Print first 10 digits and then initialize a value and loop while that value is less than another one. Don't forget to update your might get stuck on an infinite loop. So I'm just going to copy this here. Okay. Reference value, print a value to console. All right. Okay. All right. So I think that's it for this morning. We hit the 2-hour mark. I'm happy to do a little bit of Q&A or social if you have anything going on in your brain. Otherwise, I'm going to go have lunch and probably take a small nap. And then I'll see you back at 2 p.m. Any questions? Anything you want to talk about? Questions about what we've seen so far? I may do a small... I may actually insert here. I have a question about OBS. Sure, Arasto, hit me up. Iteration, do, while, loops. What are the settings that you set for your streams? Ooh, that is a good one. So, okay, so what are the settings that I set for my string? So, can I actually share that here? Yeah, why not? Oh no, wait, I cannot. What? Yes, so settings for my stream. Well, I have the settings, the secret keys for the, but then for recording, I have, I'm doing full HD. The encoder is the H264. I'm doing it CPU wise because I'm running a laptop right now, so the graphics card is just not great. I'm doing variable bitrate, which means that the bitrate depends on what's on the screen. It's not fixed. It's a very high one because I want the recording to be very high quality. This is for my recording. This is for the copy that I save on my machine, right? And then this is the most important thing that we changed. If Rami is around here, he can also tell you about it. But we discover, because we use this method of stitching, of trimming the videos, cutting them, and stitching them together without re-encoding them. You're also familiar with that, Arasto. Arasto and Rami have been helping me a lot with the videos, with editing and publishing. Rami and I worked initially on a Python script that allows you to take a Camtasia file, stitch it together, and take the trims and stitch them together without re-encoding. So it's very fast and it doesn't lose any quality. But these settings here is set to 1 keyframe because what it happens. This is difficult or long to explain. But the idea is that if you take a video and you want to trim out, you want to take like a chunk of that video without having to re-encode the video or like re-render it. Now, let me explain this in a different way. When a video is being recorded, right, the way compression works is that let's say we start a video from zero, the first frame. The very first frame of a video is a video that has all the pixels, because the very first frame that you display from a video, it needs to have all the information. But subsequent frames after that one, what they contain is not all the frames, is not all the pixels that have been recorded. What they contain is all the pixels that have changed in value, in brightness, in RGB color, whatever, from the previous frame. And encoders and compression, what they do is that they do these differences and they calculate this evolution of the frame in a very smart way, in a very compressed way. Okay. However, there's a limit to how optimal you can be by doing this sequentially over many, many frames. Because at some point, depending on the image, if it's a movie, for example, pixels change a lot. If it's a recording of my screen, you can see that most of my pixels on my screen are right now black. So this will get compressed like really, really big. What happens is that there's only so many frames that you can go until it's considered safe to keep that compression going on. What that means is that typically there is another process that is called keyframing, where an encoder will every 2, every 3, every 8, every 15 seconds, it will stop doing that compression, and what it will do is it will save a new frame, it will save a keyframe that contains from scratch all the pixels values for all the pixels on the screen. So that if something happens to the previous, so imagine that happens every 30 seconds, right? If something happened to the video in the first 20 seconds and you had to start from second 20, you would have lost 20 seconds of video, because if you start at second 20, you would have to go back all the way to the first frame and then start like looking at what the pixels that have changed so that you can actually render the frame at second number 20. I am not doing a great job at explaining this. But the idea is that when you record a video, you basically save full snapshots of all the pixels of that video without relying on the compression at regular intervals. And those are called keyframes. Okay? Now, when you do lossless streaming of videos, you cannot start from anywhere you want on the video. The idea is that because if you're keyframing every 10 seconds and you want to start your trimming on second 5, you basically only have information for some of the pixels that have changed, but you don't have information for before that. So what lossless trimming does is that whenever you want to start your trim, it's always going to snap back to whichever first keyframe it can find before that frame that you have set the trim to start at. And by default, OBS does keyframing every 8 seconds, and we found that for us that was too much, because you know when I make a pause and I shut up for like 3 or 4 seconds and then I start talking. Imagine if for whatever reason we started the trim and that had to rewind back 8 seconds, and it would find me like closing the previous video, whatever. So I'm actually using keyframe interval to 1 second, so that we have like only 1 second gap between when I start talking and like some of the frames that it might rewind back when it starts the trim. Oh, I'm doing this really unnecessary. So the problem with this is that videos that we store, they occupy much more information. They have a larger memory footprint, but I don't really care about that so much as how easy this setting makes us, how easy it makes it for us to just like trim the videos and then like stitch them together without having to spend 2 hours re-encoding the video and losing quality, you know? So for me, that trade-off is perfectly fine, and I'm actually considering even reducing that even more to 0.5 seconds or something like that. Does that respond to your answer, Arasto? Oh, and for streaming, for actual streaming, to for actual streaming, I think I do 3,500. No, it affects. No, it makes the file size bigger. Sorry, it's not about the memory footprint. It's the file size that makes it bigger. And then for streaming to YouTube, I stream at a much lower quality. So the video that you see in YouTube has less quality. The one you see live has less quality than the one that I save locally to my machine, and that we then we trim and then we publish on YouTube. Alrighty, so I think with this, I'm going to call it a morning. And I'm going to go grab some lunch, and I'll see you back at 2 p.m. this afternoon. I'm going to continue with for loops, nested for loops, and a lot of examples of that. Okay? So see you later. Thank you for sticking around. Bye bye.